This video is to explore how to interpret the tangent of an angle and think about it as the slope of a line. It can give us some intuition for how the values of tangent change, and if you can estimate where you are on the unit circle, you can estimate the value of tangent and how it's getting bigger or smaller or positive or negative. So I want to start with a review of how you get the slope of a line, and I know you know this, but it helps, I always think, to look at a review. So let's try to get the slope of a line going through the ordered pairs 3, 2 and negative 5, 4. And a quick picture of that is, let's see, there's 3, 2 and negative 5, 4. So we're looking at the slope of that line. And the first thing that I kind of do is I like to have the first point be the one that's on the left and the second point be the one that's on the right, because as I'm trying to figure out how much it's rising to how much it's running, and if I'm going to figure out the change in y over the change in x, I would like the denominator to always be positive. I would always like to go kind of from left to right. So I'd love for my run to be positive. The way to make sure that's going to happen is to make x2 larger or greater than x1, so that when we subtract we get a positive number. And then I'd also like the change in y to be intuitive. That is, as I'm going from left to right, if I would be going down slope, I would like the change in y to be a negative number. So it just helps my intuition. So when I go ahead and change back to black, when I go ahead and do this calculation, given that I've marked this as my first point and this as my second point, now I've got y2 minus y1 over x2 minus x1, and that's just going to be negative 2. 2 minus 4 is negative 2, over, and let me think about this, 3 minus a negative 5, that's the same as 3 plus 5, so that's going to be positive 8, which reduces to negative 1/4. So I'm thinking, okay, this is going down 1 every time it goes over to the right 4. So it has a slope negative 1/4. Now that was, a bit of a calculation. Not too awful, but, some work. And now I want to explore, what if one of my ordered pairs was the origin? So let's say I was trying to figure out the slope of the line that went through negative 5, 4, and the origin, 0, 0. The calculation here is going to be just a little bit easier. And I'm going to be so bold as to draw a circle and talk about, negative 5, 4 being about there, where that's negative 5 and that's positive 4. So, definitely the radius isn't 1, it's bigger than 1. But, here's the ordered pair negative 5, 4. Here's the origin. There's the line whose slope I want, and the rise to the run is going to be, let's see, so the change in y, 0 minus 4, over the change in x, 0 minus a negative 5, and that's just going to be negative 4/5, which is precisely just the same thing I would get as if I put this y-coordinate over this x-coordinate. So the slope of the line is y over x. But wait a minute, in general, in trigonometry, if I have an ordered pair on a circle, the tangent of the angle that got me there is y over x every time. So I don't even have to worry about the radius. Remember, the radius kind of enters into the formula if you're doing sine or cosine or secant or cosecant. But for tangent, it's literally just the ratio of y over x, and that is always going to be the slope of the line connecting the ordered pair with the origin.